Good evening, everyone. So, welcome to my YouTube channel, Math Sultan. So, today we are going to see third lecture on random variables and probability distribution. Okay. So, today we will study probability mass function, or probability distribution, or probability function, or probability density function. Okay. It has several names. So, let's see. So, probability mass function. Okay. Let X be a discrete random variable. Okay. Then a function fx fx okay, then a function fx define then a function fx such that first fx greater than equal to 0 for all x belongs to range then a function fx define on the range of x such that fx is greater than 0 for all x. Okay. Second one, summation x fx is equal to 1. Okay. Is called is called probability mass function, or we can say probability density function, or probability function, or probability distribution. For the discrete random variable x. Okay. So note that note that not given a density function, probability density function, given a probability density function fx for discrete random variable variable x. We have p x is equal to x is equal to fx. Okay. So what is the meaning of this? What is the meaning of this? The meaning x is equal to x means what? This means that what is the meaning of this much? What is the meaning of this much? This is equal to we are taking sample points from sample space such that they are mapped to actually x value. Okay, they are mapped to x value. Okay, this is the meaning of this. So this was the definition of probability mass function for discrete random variable. Similarly, we will write definition of probability mass function for continuous random variable. For continuous random variable. Okay. Let x be a continuous random variable. Then a function fx define then a function fx define on range on on range x such that okay. So this is a continuous random variable. So its range will be interval. So let's say assume that its range we assume that we assume range of x is is an interval. Okay, AB. It can be closed interval. It can be closed interval. It can be open interval, and it can be anything. But it is an interval. Okay. Okay. So this is the range. So such that fx is non-negative as earlier for discrete random variable. Second one, integration fx dx is actually 1. And this integral is over the range. We are taking this integral over the range x of x. This integral is taken over the range. Okay? Then okay, is called is called probability mass function, or we can say probability density function, or we can say this is probability function or probability distribution for the continuous random variable x. Actually, the definition is simple because when we have discrete random variable, the range of random variable will be a finite sequence or an infinite sequence. Mostly in the case of finite or infinite sequence, the summation follows. But once we talk about continuous random variable, the range of random variable x contains an interval. So therefore, this is a continuous random variable. So for continuous random variables, integration follows in place of summation in the case of discrete random variable. So for discrete random variable, we have summation. When we have continuous random variable, summation will be replaced by integration. Okay. Okay. Note that fx is equal to nothing but for continuous random variable for continuous random variable x. We have fx is equal to limit h tending to 0 probability of x plus h upon h. So by this definition, it follows that by this definition, this follows that the probability a less than b is equal to a to b such dx fx dx. So this will be formula. We will use this formula frequently. Okay. So okay. So this now examples. Example one. Tossing a coin. Tossing a coin. What is the sample space? H and T. Okay. So what was the random variable for this case? S to R. We have taken already in yesterday's class. It was H was taking a 1 and tail was taking 0. So it has two values, 0 and 1. Okay. So I am going to define a random variable density function. So I am taking 1 to 1 by 2 and it is 0 to 1 by 2. Now check F is probability mass function for discrete random variable x. First of all, it should be greater than 0. So we have two values, one that is also greater than 0 and 0 that is also greater than, that is 1 by 2 that is greater than equal to 0, and this is also this implies fx greater than 0 for all x. Okay. First condition is satisfied. Now what is summation f1 plus f0? Because it has only two values, 1 by 2 plus 1 by 2 is equal to 1. So this implies summation x fx is equal to. So all the conditions of probability mass function is verified as f is a probability mass function. Okay. So this is proof that this is a probability mass function. Now next example I am taking example 2. Tossing three coins. So we are tossing three coins. We have sample space H H H. Okay. We have H H T. Okay. We have H T T. And we have T H H T H T T T T. Okay. And we have T H T. Okay. Sorry. So we have H T H T H H H T H T H H T H. Okay. And T TS. So we have 8 possibilities. Okay. So we have a random variable this to R. So this random variable is counting of heads. We are taking X as a random variable, counting number of heads. So if we take this H, 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 this will be counting of number of heads. This will be 3. Okay. And second one will be X, H, H, T, that is 2. X, H, T, T, that is 1. X, T, H, H, that is 2. X, T, H, T, that is 1. X, T, 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 that is G. X, H, T, H is equal to 2. And X, X, T, T, H is equal to 1. So I am defining. So what are the values here? Possible values of X. Possible values of X are 0. Possible. What is the range of X? Range of X is range of X is 0, 1, 2, 3. So I'm defining a function for 0. This is 0. And for this is 1. For this is 1 by 8 I am taking. For 2 I am taking 2 by 8. Okay. For okay. So number of heads we are taking. So the 0 and number of head is 1. So I am taking this counting. How many numbers of head? 1. So 1 has this one. 1, 2, 2 by 8. 2 by 8. Okay. And number of heads 2, 1, 2, 3. 3 by 8. 3 by 8. 3 by 8. Okay. And number of heads is equal to 3. Number of heads 3. So it is 3 by, sorry, number of heads 3. Only one possibility, 1 by 8. Okay. And number of heads 0. Number of heads 0. Numbers have 1, It is 3 numbers had 2, 3 by 8. Numbers had 2 is also 3 by 8. This is also 3 by 8. Okay. And number of had 1, only one possibility. And number of had 0, 1 by 8. Okay. So what are the possibility of x value? So range is 0, 1, 2, 3. So x possibility is this implies x is equal to 0, 1, 2, and 3. Okay. So we have this one. So check that. Check. Check f is a probability mass function. Okay. For x. So what we will check whether we know that f0 is equal to 1 by 8. That is non-negative. That is non-negative. F1 3 by 8 is non-negative. Okay. It is 2 3 by 8 and F2 it is also 3 by 8 non-negative. Three by 8 that is also non-negative and F3 that is 1 by 8 also non-negative. So what is the meaning of this? All fx is non-negative for all x. So second one is whether summation is 1. So fx f0 plus f1 plus f2 plus f3. So this is 1 by 8. One by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. So this is 8 by 8, that is 1. So this implies summation x is equal to 0 to 3, fx is equal to 1. Okay. All the conditions of probability mass function are satisfied. Hence, f is a probability, mass function. Okay, example 3. So we have SR is equal to PR. CR is a circle. The circle centered at origin, having radius R. R lies between this range. Okay. So what was the random variable for this? X was this one. Pi R square. Okay. So we are defining a random variable. So what is the range of X? Range of X is open interval 0 to 25 pi X. So we are defining probability mass function for this. So I'm defining this function fx is equal to (25) pi upon 1/25. Okay. For all okay. So you check that S is probability mass function for F. You see that this is a continuous random variable for all X. So this implies Fx. Second one, integration range of X Fx. What is that? So this is 0 to 2 pi 25 pi 1 upon 25 pi dx. Okay. So this will come out 0 to 25 pi dx. After solving it, what you will get? You will get 25 pi. So this is 1. So this implies range of X Fx dx is equal to 1. So this implies F is probability mass function for continuous random variable X. Okay. Now another one question. Example 4 I'm taking. That diameter of a electric cable X assumed to be a continuous random variable with function Fx is equal to 6x 1 minus x for all 0 to 1 to 1. Check that F is a probability mass function for X. Okay. Solution. So Fx is equal to 6x 1 minus x for all. Now first condition, you see that x is greater than 0 for all x in this range. Okay. And 1 minus x is also greater than 0 for all x in this range. So this implies 6x 1 minus x will be also, but this is nothing but fx. So first condition is satisfied. Now another one, integral range of x fx dx, that is range 0 to 1. It is taking 6x 1 minus x dx. So 6 you take outside, 6 you take outside, this is x squared. Now solve it. X squared by 2, x cube upon 3, 0 to 1. 1 by 2 minus 1 by 3. 6, and this is minus 1 by 6 minus 0, that is 6 upon 6, that is 1. This implies this implies integration range of fx dx is equal to 1. All the conditions, all the conditions of a probability mass function are satisfied, hence fx is a probability mass function for given continuous random variable. Okay. Note that probability density function is called PDF in short. In short, probability density function is called PDF in short. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you in next lecture.